All right, so in Calculus 2.4, Part 2. All right, so the chain rule versions of the derivatives of the 6 trig functions. So we already knew the derivative of sine is cosine, but if this is not a plane x, then you got to take the derivative of what's there. The derivative of the tangent is secant squared. Again, if it's not a plane x, then you're going to have to take the derivative of what is right there. And so that's what's happening on every single one of these. So again, the original rules that we learned was just that was a plane x. No longer does it have to be a plane x. We're using the chain rule with those as well. So I want the derivative of the y equals the sine of 2x. So that's not a plane x. The derivative of the sine is the cosine, so it's going to be cosine of 2x, but then times the derivative of the 2x. The derivative of 2x is 2, so therefore my answer would be 2 cosine of 2x. The next one, I want the derivative of y equals cosine of x minus 1. Again, that's not a plane x right here, not a plane variable. So I have to do that chain rule. So the derivative of the cosine is negative sine of all that stuff, but then times the derivative of that stuff, and that would be the derivative, that would be 1. So therefore this would be my answer. Again, the derivative of the tangent is secant squared, but that's not a plane variable. So secant squared of 3x, but then times the derivative of 3x, which happens to be 3. So my answer would be 3 secant squared of 3x. So again, if these are not plane variables, you have to multiply by the derivative of that at the end. All right, so this time this slide is actually trying to complicate it. They're trying to trick you. Some of these are simple, some of them are more complicated. The first problem says take the derivative of the cosine of 3x squared. So first off, the derivative of the cosine is negative sine of what you took the cosine of. So it would be negative sine of 3x squared. But that's not a plane x. So I'd have to multiply it with the derivative of 3x squared afterwards, which would be derivative of that would be 6x, and there would be my answer. All right, the next problem is a little different. It says the cosine of 3, and then that number is times by x squared. See, the cosine of 3 is actually a coefficient. Let's do this for a second. If I covered up the word cosine, and that wasn't even there, you would have 3x squared, and its derivative would be 6x to the first. See, cosine of 3 is a number. That's just a number. That's just a coefficient. So this derivative would be 2 times the cosine of 3, and then x at the end, x to the first. It was not the cosine of 3x. All right, this time you're taking the cosine of 9x squared, actually. So the derivative of the cosine is negative sine of what you took the cosine of, but then times this derivative. That derivative happens to be 18x. All right, this one is going to be actually a chain rule. It's whatever the cosine of x is, then square that answer. So when I take this derivative with the chain rule, remember that's going to be the 2 out front to this to the first power. Remember, that's my smiley face right there. And then times the derivative of what's inside there. So again, that's going to be 2 times cosine x to the first times the derivative of what's in there. Now that derivative is negative sine of x. So therefore my answer is negative 2 cosine x sine x. E is kind of similar to D in the sense that it is to the half power after you take the value of the cosine of x. So we're going to do the chain rule just like we did in problem D. We're going to take the half out front. We're going to raise it to the negative half after. But then it has to be times the derivative of what was inside there. Again, that's that chain rule, guys. This is the smiley face right here. So you've got a half, all of that stuff to the negative 1/2 when I drop it. And then the derivative of what was in there, the derivative of the cosine of x is negative sine x. And then that's just all multiplied together. Don't leave that negative exponent, so I did have to bring it back down to the denominator. So finding this derivative. See, if I think about the order of operations, I would have to take 4 times t first, then I would have to take the sine of that, and then I would have to raise it to the third power. So we really need to understand what we're doing with this problem. So again, it was taking 4 times t, then the sine, and then raising it to the third. So when I go to take the derivative, I now need to do the derivative of this smiley face to the third power. So it's 3 times a smiley face to the second power times the derivative of what was inside there. Now the derivative of the sine is cosine, but because that's not a plane variable, I would then have to multiply it by the derivative of 4t. The derivative of 4t is 4. See, I have to keep working this until I get the derivative of a plane polynomial function. The derivative of 4t is 4. Now my final answer will be 12 sine squared 4t cosine 4t. So today we did the derivatives using the chain rule. Take a look here. If I had x squared plus 1, that would just be plain old 2x plus 0. But this one would be the quantity of x squared plus 1 to the 1/2 power. So its derivative would be a half, all that to the negative half, times the derivative of what's in there. We can take the derivative of the plain sine of x. This is trig of a plain variable. This is not a plain variable, so its derivative would be the derivative of the sine of 6x, that's cosine 6x, but then times the derivative of that 6x, which is 6. The derivative of this simple polynomial would just be 3. But the derivative of a polynomial raised to the 5th power, that's the smiley face. So it'd be 5 times my smiley face to the 4th times that derivative of the smiley face, which is another 3. Derivative of x is 1. Derivative of tangent, secant squared. Very simple, plain. But this one, see, that's not a plain variable right here. So I would take the derivative of the tangent, secant squared of x squared, but then times the derivative of that x squared. So and this was just supposed to be a little summary of when to use chain rule and when not to. In your homework for tonight or tomorrow and first thing in class, please do the do now problems. They're either listed here in the slide or they're listed on the homework problems. You guys have a great day. We'll see you tomorrow.